So welcome teachers, and I hope you're doing well. We are going to discuss some of the ways how we can write feedback in Desmos activities and encourage our students to reflect on those feedbacks and correct their answers or solutions. So we are recording this. We may have to split this session in two parts. So please, if you by mistake you disconnect or I'm disconnecting, join back with the same link. So we'll see how to add simple code to give feedback, and that feedback can be given in multiple ways. So I'm going to start with the activity which I was showing you in different groups. So you can see here, very simple question. So, but we can send a feedback using a text message to the student immediately. And the student will definitely feel excited or will try to correct at least if there is some mistake in his working. So let's say the answer I'm writing here is 20, and student will see immediately the message in bold letters, which is says try again. So we are actually asking student that your answer is not correct, and then student can actually correct this. Of course, we can control to move to the next slide. That I can also tell you. But initially, the first thing is you need to know, you need to understand if I'm giving the correct answer, I'm getting a feedback. And if it is correct, I'm getting that correct or some sort of message I'm getting here. So same thing here. Here also, let's say it's an area and students are trying 8 times 6, 48, half of 48 is 24. So if it is 24, then the message is here, well done. Well done, the area of triangle is 24 square units. So of course they can change the values, but then answer will not be saved. So they need to click again to verify. So we are opening opportunities for students to try in different ways. And this is the table. If I enter anything wrong, then student will get a message. Let's say, look at this, check again or try again. And for others, it says correct. We can actually correct this. And then I'm gonna see the feedback is immediate. And I'm gonna go to the next question. Here, I have added 2 images. One will show as the correct. Second one, it's for the wrong answer. Let's say I'm entering answer 2. So the message is coming in the form of a picture or a GIF, which says, sorry, please try again. So student will see, okay, I need to try accurately. And if it is correct, the message is there, that's correct. These images, these GIFs or other things you can add, you can use from open source available on internet. So that's the target for me today, to explain few of these things. And I hope you guys must be excited for that. Let us begin and how I wrote this code. Let me share this activity with you guys if you want to copy the codes. So I'm going to share this activity with you. Sharing in the chat right now. Everybody. So let's say I'm on a different account. And here I'm opening that activity as you guys will see that activity. Same way I'm going to see. Look, it's created by me. And then when you click on these 3 dots, remember you should be signed in. So whichever account you're using, you should be signed in. So click on these 3 dots. There it says copy and edit. But if I show in my account, because the original activity created by this account, here I will see 4 things. Edit your activity, manage editors, share activity, copy and edit or delete. I can delete this. I can copy and edit. I can share. I can edit because it is my activity. But if this is in the new account, I don't see all the options because I haven't added in my account. So guys, you can actually click on this, copy and edit to see the codes, to see the backend things, how I'm writing the feedback. So here we have the first question, which is the answer is numerical, right? So I'm gonna figure out like that. So if the answer is numerical and you don't need to enter any expression, and with the simple thing, you can give feedback, right? Let me add one few other things, and so that you guys can understand, okay, we can do this even as a fresh activity. Look, I have added a new page here. I am adding a question with the note. Let's say add 3 and 5, right? Now, the question is where students are going to enter the answer. So if I see the preview, I see only the question, not a space where students are going to enter the answer. So we have this math input, text input, multiple choices, check boxes, etc. There are lots of things. Table also we can use. So I'm going first with math input. I'm clicking on math input, and here I'm going to see the preview now. Look, I have a space where I can enter my answer 8, but there is nothing happening. Look, it's just a dot. Dot means nothing registered in terms of right or wrong, or even students are not going to get any message that it is wrong or right. So to make it more interactive, what we just need one thing. Look at this. It says name this component, name this component. I'm going to give a name to this component. Let's say Q1 because it is my question number 1, right? You can give any name. It's not a problem. And go here, edit computation layer. It's very simple. Do not worry that it's a complicated task. Very easy. And here you just need to add something. Let's say solution, right? Just write SOL. Solution equals this. Why I'm saying this? Because I'm interacting with that particular component. This dot numerical value, okay, equals to 8. It's gone. Don't enter anything. You will see the warning sign, right? But if you complete this code with this number 8, it means you're done. In terms of programming, I'm saying my variable is SOL, which is actually defining the numerical value as 8. And I'm gonna cross verify, or the validation will be done using this variable for my students and for, you can say, the teacher also to see whether student has entered correctly or not. Okay, so this part is done. Very simple. Now, what is the benefit of this? Let me just show you here, because we want to see at the teacher dashboard as this answer is correct. So guys, you just gonna write correct in lowercase of c, correct. When it is correct, when SOL is correct, that's it, simple, right? So when SOL is justified, means the Desmos will know this answer is correct, and the teacher's dashboard will show it. Let me show you here. If I enter 7 or 9, you see there is a cross. But if I enter 8, it's correct, right? So this part is done, but feedback part is not done yet. Now to send the feedback, you have to send in terms of message or an image. It's up to you. Let us start with simple text, right? So I'm going to go with this component, which is my question, because I want my student should get feedback here. Feedback here. This empty space will show the feedback. So I'm going to go here now, edit computation. It's very simple, and I'm going to repeat this for different types of questions. So I'm going to hit the question statement component. Okay, go there. And here, just add another variable. Let's say feedback, right? Or feed, as you like. Feed. I'm just writing feedback equals to. Okay. Now, here we are using condition, if and else. In Desmos, if and else conditions are written as when and otherwise, because we are going to define the condition. So when, you remember the component called Q1 dot numerical value equals to 8, then the feedback should be correct. And whenever you write the feedback or any text, you have to use double quotation marks, right? Now, otherwise, what you want to show the message, if you want to leave it blank, just leave it like this. There is nothing inside the brackets. So feedback is given and we are done. Now here, along with this feedback sentence, use this insert a value from the layer. So I'm going to click here, and because we have just one component which is defined, so just click this and the task is done. Look, if there is not 8, let's say 7, there is no feedback, right? And if I enter 8, the feedback is that's correct, right? So now there are two ways also, because you must be wondering, no, we want to also give the student feedback as that it is not wrong, or sorry, it is not correct. So for that, what we are going to do, we're going to go back, and here we can define one more condition before you message otherwise. Okay, I'm just deleting this and clicking as when, right? When Q1 dot numerical value less than 8, can be any number, right? So we are just saying less than 8, or Q1 dot numerical value greater than 8. And the message should be what? Try again. And otherwise, we know what we did, nothing. So we have defined two conditions, and let's verify it's working or not. Look, if you don't enter anything, there is no feedback. But if I enter wrong answer, my feedback is try again. If I'm entering correct answer, I'm saying that's correct. Now, of course, I know some of you guys must be wondering, we don't want to show the feedback without clicking on the submit button, because they are getting the answer immediately, right? That also we can do. Just go back. Now add one more condition as and. So I'm going to add and Q1 dot submitted, because if you submit, then only you will see that answer. Okay. Q1 dot hold on, submitted. Yes, it should work. What is wrong? Let me just be got a string. Okay. I'm just removing this. Maybe here. Oh, sorry. I should add here because I was adding after the text. And Q1 dot submit. Right now, I can copy this and paste in the second condition as well. Right? We are done. Now, what is going to happen? Let's say students are going to enter 8, but they're not getting the feedback because we haven't submitted the answer yet. So once they submit, then only they will get the feedback. 9, try again. If they enter nothing, there's no feedback. So see, the task is done. Let me show you the code again, what I did. So conditions are defined when. Let me just, I think this will help you now. So I've defined two conditions: when Q1 numerical value equals to it and submit it, then the message should be that's correct. When Q1 numerical value less than 8 or greater than 8 and submit it, then only we are getting a message try again, otherwise nothing. So guys, if you want to copy this note, please, I can send you this in the chat if you want to note it down. Everybody, yeah, I have sent you in the chat. If you are on your laptops, you guys can try right now with this simple technique. I can do one more thing. Let me just copy this code, make it simple for you so that you just want to try one thing. Okay, so this is a simpler code. Let me just paste that also in the chat. So the second one is without submit button. First one is with submit button. So please check if you have any concern. Otherwise, I'll show you my other codes, but I wrote in my activity. So I can show you what I did. Look, it's very simple. Feed when correct and input submitted, that's correct. When input got submitted, try again, otherwise none. So it was another way of doing it. So we don't need to tell the answer has to be correct. We can just say that if you just submit and not entering the correct answer, then we can show the try again pop. Remember, this input means the component as, look at this, input. As in our case, it was question number 1. So these are names, that's it. So, and these names are important because you're gonna connect them and so that you can extract their feed values. Okay, so I hope. Yeah, so let's move on. If you have any concern, please ask, unmute yourself and discuss, because I'm open to discuss these things. And I'm not in a hurry that I have to cover certain number of things. I just want to help you so that you feel confident and try to add these simple things in your activities in order to make your feedback more streamlined, so that students are getting feedback. Teacher is also seeing that what is wrong, what is right in that particular. Let me show you the code in other activity. You see, I'm just going to repeat this because I'm using a fraction there. So that's what I just used, like fraction, because the answer of that question was in fractions, 17/20. Otherwise, students could have entered 0, because you need to consider all those flexibilities, all those ways how students may enter the answers. Okay, so let me show you the code. Look at this. Input is the name. Okay, let me just change it to Q2 just for you so that you can see this. Okay, I'm gonna go there, changing input into Q2. Q2, here also Q2, and here also Q2. Here also Q2. And we are done. Look, now I think you guys can correlate easily what we did and what I have done already. So I have defined in not SOL solution, I defined correct with capital letter C. So Q2 dot numerical value equals to numerical value of a fraction, or Q2 dot numerical value as 0.85, because you never know, students may enter in fractions or in numerical value. Simple, 0.85 like decimals. And then what is the feedback I'm giving? Feed, again, I'm defining conditions. So when, look, let's make it simple now. I hope now you will understand easily. So the first condition says when correct means this variable. Look at this. Instead of that, you could have entered everything. This one. You can copy this and just paste here. You don't need to define that. Still, it will work. So that's the way how I did. So, but it's up to you. You can actually become more proficient in this as you practice more and more. So everything is optional. So you can actually use this. So whenever I type my defined variables, it shows me variable. So I can just use it. Okay, so let's now go back to geometry question. Right, so here what I did, this is something draggable I did so that students can freely drag. Now, based on the complexity, we can make this type of question for high school students, for middle school students, and also for primary students, right? So it's up to you. I just try to make it simple so that students can drag anything. All those vertices were draggable, and this was kept as same height so that if they are moving left, right, it's not changing, they can move up and down. The maximum number they can achieve as 7, but if you move it down, then they can also reach to. So here, my concern or my question was verifying that area is 24. Now let's do that. I'm going to add one component here, one page, sorry. And then because it was done in graph, so I'm going to use the graph and go to edit graph. Now here you can use your skills which you did use in your calculator. Calculator means Desmos calculator, graphing calculator. So what I'm going to do, I'm going to define points so that I can actually drag them. Now it's up to you. You want to make them draggable only one vertex. Let's do in that way. So I'm going to define two variables, two sliders, sorry, a equals to 2, b equals to 1. Now my point is a comma b. So this becomes a draggable point for me and drag it anywhere. Now let us connect this with the polygon, right? And to connect with the polygon, what I'm going to do, I'm going to add a table. And now in this table, maybe my first vertex could be A and B, right? And next one can be, let's say A plus 1 and B. I'm just increasing A value by 5 or 2, whatever, right? And maybe we can also decrease it on the other side, or just keep it A plus 2, B plus 2. Now what is pending? A comma B plus 2. Let's make it square, right? So I can drag this point and move it. But what is happening here? Every point is dependent on A and B, sorry. What we can do, we can make it more flexible by adding two more things. Let's say C equals to 3 and D equals to 4. Instead of this, I'm going to write C comma D so that they can also drag E and D. So they can drag this point and this point. Now let us connect it. So we have got a polygon. What I'm going to do, I'm going to click here and hide this. Hide this. Okay, I can just show lines. Why it's not complete? Because we didn't connect the last one again. So let's do that. So the last one was A and B. Right, it's connected. We can actually create any any type of polygon here. I have four-sided, right? So yeah, I hope this will definitely may, of course, you can use your creativity. What I did, let me show you. I have used one free point AB, second free point CD. I've just used a table to create a polygon. AB, A plus 2B, CD, A, B plus 2, so that the height is there, and A comma B. Now, you know the coordinates you have, AB, A plus 2B, CD, and A and B plus 2. And from here, you can easily figure out the area, right? Let me define the variable as A equals absolute value, because you know it may be negative, right? So I'm going to just use absolute value of what? Now, how to figure out the area? So you know what? You are going to multiply, right? So technically, you can use the coordinate formula. Let me show you what I did, because I knew I'm just using height. Let me show you. Look at this. I had these coordinates. So I figured out the base and the height. I just multiplied those two. Absolute value of first, the base, absolute value of the height. So the similar manner, you can actually use this and you can figure out how you want to calculate the area, right? So in terms of the coordinate things, let's try that. A equals to absolute. As you remember, the coordinates, how you are going to multiply and how you can find out. So A times B and minus A. I'm just considering points like that. So A, B, I may be wrong, so please correct me if I'm entering anything wrong. A plus 2 times B. So this is one thing, plus the next one would be A plus 2 times D. A plus 2 times D minus BC. Yeah, BC plus D times B plus D, B plus 2, sorry, minus A times D. I think we are done. Let me just make it a perfect shape so that we can verify the answer. Look at this. So the area should be how much? 1, 2, 3. Or we are not doing half, right? Okay. So the area of this polygon is 4. So if we make it something like that, you can make this point also draggable. I don't mind. It's up to you. So look, right? So in that case, area is not 9, or look, it's again 4 because it's not coming accurate. Guys, we may need to connect again in 10 minutes. So we are continuing now, but after 10 minutes, if I get disconnected, please connect again. So this way, I'm just saying, so let's say this is done. Initially, you can actually make any shape and you ask your students to create a square of particular area, right? Now, the geometrical part is done. Let's add a note to add instructions. Drag the points to make the square of area equals to 4 square units, right? Let me show you the preview. The students, they are gonna drag the point wherever they want in order to make a square of 4 units. So something like that. One more thing, you can control it so that it doesn't turn into decimals. So when you go to A, always add in the steps 0.25 or 5. That will help you so that student will ending up at the particular places, because otherwise they may leave at like 1.87 and it will not count as exact 4. Right? Now the points will go in a better way. Okay, look at this. You drag it. Now let's say I'm putting it here and look. So let's say you want to show that value also at running value, means you want to show this point all the time on the graph. I'm going to create one point somewhere, let's say at 4,6, and I'm going to use that label. Here the label should be use this $sign curly and then enter a. The numerical value will be X. Let me just pass this to you in the chat so that you can. So in the label, I'm using this value. So what is the benefit of that? Okay, let's hide the point. Hide this point. Hide means no, because it will show the label only. Look at this. So what is happening? The area is changing in a real time. Look, I know there is some mistake, maybe, I think. Look, it says 1 square, but it's not because the values are okay, because yeah, correct, it is 1, because the numbers are not visible here, right? So let me take some other values. Yeah, it's increasing and it's changing. Yeah, what the mistake what we have done is the points are taken as the other way. Let's correct it. What I'm gonna do, instead of a plus 2, let me use c here, cb, and instead of b plus 2, let's use d. Now it will always make a square or a rectangle, right? I hope now it will be better. Okay, so ab minus cb. Okay, we can actually I can change a plus 2 with a plus 2 with c and b plus 2 with leaf. Okay, let me just verify now. Area should be -4 to 6, 6 to 24. Okay, let me just check what is wrong in the formula. Area should be now 10 times 5, 50, right? And it says, okay, let me just move it close to it. Guys, just help me out to correct this area. AB minus CB plus CD minus BC plus CD minus AD. Think, no, am I missing anything? Yes. AD. Okay. Plus AB minus AD. Half. Now it's correct. Okay. Now we can verify the area is 25. It's 5 by 5. It's correct. Now it would be easy. Look at this. So now let's verify or validate. Okay, so the question statement is clear. Let's add a math input box. Let's give a name as question 3. And you can go here to mark it as correct. When it is correct, correct. When this dot numerical value entered as the thought was, let's end the question as 40. 40, right? Okay, now how to validate it if the answer is 40? So, oh, sorry, because I think there is no need to enter the answer. Yeah, because we are just dragging it. So in this case, what I'm gonna extract as the point from here. Let's go to this because we just want to give the feedback. Feedback is, what is the feedback? When, look, the number defined in the graph component, right? In the graph component, and we haven't defined the graph component. So you can see question 3 here. Question 3 dot number, that number was A, and it should be how much? 40. Then it is correct. Otherwise nothing, right? So we can just mark the feedback here as using this and feed. It. Look, now it's done. So the feedback is empty because the area is 25. Area should be 40. So that's what we did. Okay, let's move it. Anyway, they can move in any direction and they get the area as 40. Look, if it is 40, the feedback says correct. If it is not 40, it's not saying anything. So that's how you can grab any number from the graph, because in the graph, A is my area. A number is my area. And here, show the numbers here. If I hope it will work in a better way. Yeah, now I can see gap of 111, right? So it's easy now. See whether my numbers are correct or not. Look, so it's 8 times 540, correct. So yeah, guys, we may get disconnected in 1 minute. So if you have any question, please ask. I know it's not been corrected yet. Let's do it. So go in the interaction part. We are interacting on the graph. So the code should be given in the graph. So here, I'm just giving one code which says correct. This number, sorry, this dot number A is how much? 40. Simple. If the number is 40, feedback is correct. And teacher is also happy, student is also happy. So let me show you the coding part or other things what we did. A and B, free points. C and D also free points. This number 25 square unit, let's add a one word here, area equals, so that we can show it. Maybe we can change the position also. 8, 8. It won't disturb us. Okay, it's gone out of the way now. So let's just change one thing. It's done. Now we can see clearly the area also.